The next section of probability involves what's called expected values. Now, an expected value is a way mathematically that we can decide just before we put money on a horse or money on a drawn card or money on a lotto ticket or money on a spinning wheel whether we should do so or not. There is mathematics behind it. You can actually judge whether something's going to be worthwhile investing in or something that's actually something you should run away from. That's what expected value is all about. Basically what we do with expected value is we look at the prizes and their associated probabilities. We multiply the prize value by its probability of happening, and then we add those products together. That's the expected value. Okay, that's, in other words, that's the expected value of every turn that everybody will take on this particular wheel. Now, there are three possibilities in terms of that expected value. If the expected value is equal to what you paid to do the actual competition, then that's a fair bet. So in other words, you're getting your money back for what you did. If the expected value is higher than what you paid to spin the wheel, then that's brilliant, because you're going to end up earning more money. But if the expected value falls below what you invested, well, then that's something that you should stay away from, because the chances are you're going to lose money more often than you're going to gain. So these things you have out in Bray, these things with the handles, yeah, the one-arm bandits where you put the money in and you get the 3 cherries or whatever, they are electronically rigged so as to never pay out more than they take in. So therefore, they're always going to be a bad bet. Even though you might hit a jackpot every now and again, they're always, over the lifetime of these machines, they're always going to be a bad bet, because they're designed to bring money in, not to give out more than they take in. Okay, so it's just an example. So here's another example here. You have the opportunity to place a €5 bet on the spinner above. Is it a good bet or is it a bad bet? Well, that all depends on its expected value. So what is its expected value? Well, first of all, we've got to work out the probabilities of each sector. Now, here it works out nicely because we can see them. The disc is given over half of its area to 2, so that's 0.5 of a probability, then a quarter of the probability, and a quarter of the probability here. Okay, so the probabilities are easy to work out because it represents the sector of the disc for each particular prize. What we then do with each of those probabilities is that we multiply them by their value. Okay, so that would be 0.5 by 2, 0.25 by 6, 0.25 by 4. We add those products together and then we compare it to the investment that we made. Or you can take away the investment if you wanted to see what category it falls into. Does it give you positive return? Does it give you a 0 return, which is the same as getting your money back? Or does it give you a negative return and that gets you run away from this thing? All right, so first of all, we've done the probabilities. There they are. Probability of €2 is 0.5, probability of €4 is 0.25, and the probability of €6 is 0.25 as well. Multiply those together, 0.5 times 2, 0.25 times 4, 0.25 times 6, then add the results, so it's 1 plus 1 plus 1.5, which is 3.5. Now, so that means every time this wheel is spun, we're expecting to pay out €3.50, but somebody has to pay €5 to do it. So therefore, this isn't good. We're paying €5 and expecting to win 3.5. So what's my expected value? Well, it's the 3.5 minus your original investment, which brings you down into negative territory, which makes this a very bad bet. That's it. So you would stay well away from that one. So we have a formula. Okay, now there's two things I want you to notice here. That symbol there is the expected value. When you take away your original investment, you're gone down to your expected return. Okay, now the way I prefer to do it is this: work out your expected value and compare it to what you have to pay to spin the wheel or pull a card or throw a dart or whatever it's going to be. Yeah, and if the expected value is less than you have to pay, stay away. If it's more than you pay, take every shot in the book, do it all, keep going for the whole day, you'll rake in the money. But if it's 0, well then basically what you're doing is you're just paying to throw a dart, getting your money back, paying to throw a dart again, etc. So we have to work out what 3 categories this falls into. Okay, so in this case, that would what I would call my expected return is equal to my expected value minus my original investment. Or just get your estimated value and just compare it to what you originally invested and see where it falls. This means, as we said already, the probability of each event is multiplied by its respective value, and all the products are then added, the original investment subtracted to see the expected return. And there's 3 possibilities. If your expected return is equal to 0, that means you get your money back. Fair enough. If your expected return is less than 0, stay well away. But if it's greater than 0, go for it. buy everybody else out, take over, keep throwing the darts for the whole day, keep pulling the cards, keep popping the balloons, whatever you're going to do, and break in the money. So here's another example. At a garden fete, you can pay €10 to pick one of 10 blank envelopes. 2 are empty, 5 of them contain €5, 1 contains €10, and 1 contains 20, and 1 contains 50. Is the competition a good bet? Okay. Well, in this case, again, let's work out the expected value and see how it compares to my investment. My investment is €10. Okay. Now, there are 10 envelopes, and it says 2 of them are empty, 5 of them have €5, 1 contains 10, 1 contains 20, 1 contains 50. Is the competition a good bet? Step number 1, work out the probabilities. What is the probability of winning nothing? And the answer is 2 out of the 10 envelopes have nothing. What's the probability of winning €5? And the answer is 5 of the 10 envelopes have €5. What's the probability of winning 10? Well, 1 out of the 10 envelopes has €10. The probability of winning 20 is 1 out of 10. And the probability of winning 50 is also 1 out of 10. So they just come straight from that paragraph there, and they're easy enough. It's basically the number of envelopes out of the 10 that represent the various different prizes. They're the probabilities. Now, to work out my expected value, I've got to multiply each of those probabilities by their respective prize values. So that's nothing. They're fivers, that's a tenner, that's 20, and that's 50. And then we multiply those out and get them down into decimal form. That's going to be 0. That's going to be 2.5, because 5 into 5 goes once, and 5 into 10 goes twice. So 2 into 5 goes 2.5. That's going to be 1. That's going to be 2, and that's going to be 5. So therefore, if I add these up, 5, 7, 8, I get 10.5. So my expected value is 10.5. How does that compare to my investment? Well, my investment was €10, so it compares favorably, because 10.50, which is your estimated value, minus your investment of €10, gives you an estimated return of 50 cents per go, which is in positive territory. Doesn't matter, it's only 50 cents, it's in positive territory. This is a very good idea. So therefore, whoever's running this garden fete likes their people. Okay, so I have it done down there. Let's just get rid of all this annotation. You can see it yourselves later on. So there's the answer done out for you in terms of print. Okay, so it's a good bet. Here's another example. A GAA club holds a weekly lottery. For €1, it's my investment. So for €1, you can choose 3 numbers from 1 to 20. If you have 3 winning numbers, you win 500. If you match 2, you win €5. Is the lottery a good bet? Now, the first thing I've got to do here is there's only 2 outcomes. You win or you match 2. So I need the probability of a win, and I need the probability of the match 2. Okay? Probability of the win is easy. First of all, say you choose the numbers 1, 2, and 3. And when they pick out the numbers, they pick out 2, 3, and 1. Do you lose just because the numbers aren't in the right order? No. So is order important? No. So therefore, this is not a permutation, this is a combination. So out of the 20, I'm allowed to choose any 3. So the first thing I'm going to do is find out, well, how many different ways can I choose 3 cards or 3 numbers out of the 20 that I'm going to choose from? And 20C3, just to do that here very quickly, 20C3 works out as 1,140. So there are 1,140 different ways to pick 3 numbers out of 20. You are hoping that your one ticket will be the one out of the 1,140 that wins. So therefore the probability of winning is 1 out of 1,140. There's only one combination of those 1,140 numbers that will actually win you the prize money. Match 2 is a little bit more difficult. Match 2 means that out of the 3 winning numbers, you have 2. You've chosen 2. Yeah? But out of the remaining 17, you've chosen 1 that hasn't been called. So therefore, you've got 2 out of 3 correct, and you have 1 out of the remaining 17, which wasn't the right number. So that's how you're going to work out, first of all, how many different ways can I match 2? And then we'll work out the probability from there. So 3C2 is the same as 3C1, which is 3. And 17C1 is 17, so 3 times 17 is 51. So there are 51 different ways to match 2. Out of what? Out of the 1,140 ways of choosing 3 cards. So that's the probability of a win, and that's the probability of matching 2. Now, let's get the expected value. So we're going to multiply these probabilities by their prize value. So a win is worth 500, and a match 2 is worth a fiver. So let's see what they turn out as. So 500 divided by 1140, that comes out as 0.4356. 0.4356. Okay. And then we've got 51 times 5 divided by 1140. And again, that will come out as 0.2237. And this is just calculator work. So the expected value, therefore, is what I get when I add these two together. So 0.2237 plus 0.4356 comes out as 0.6592, or 93, because I'm going to round it off. Okay, so that's my expected value. All right. How does that compare with my investment? I invested €1. So every time I invest €1, I expect to win 65.93 cents. Not a good idea. If you want to get your expected return, you take your expected value and you take away your investment, which drops you down into negative territory, which is minus 0.3407. So because it's negative, it's a bad bet and a bad lottery. So stay well away from that one. Okay, let's take some from the book now. So page 88, question 5, you can look it up yourselves. And again, no harm to pause these things before I do them to see if you can do them. And then give it a shot and then turn on the solution as soon as you've given this a go. A friend of yours offers you a bet. You have to bet, offers you a bet, yeah. You have to bet €1. Then you can pick a card from a pack. If you choose the ace of spades, you win €20. And if you pick any diamond card, you win 2. Is this a good bet? Justify your answer with reference to the expected value. Okay, what's the expected value? It's the probabilities of each event multiplied by their prize value. Okay, you add them together and then you compare that to your investment. Here, the investment is €1. Just keep that in mind. That's my investment. Okay, now, what's the probability of choosing the ace of spades? Well, think of a pack of cards. How many ace of spades in a pack of cards? 1. So that's 1 over 52. What's the probability of any diamond? Well, a diamond is a suit. It's one of the 4 suits. So there are 13 cards in a suit. So you can say 13 over 52 or 1 over 4. They're both exactly the same. 13 cards out of the 52 or 1 suit out of the 4 suits. That's fine. So there's your probability of both. Now, let's work on the expected value. We're going to multiply these by their prize value. That gets multiplied by 20 and that gets multiplied by 2. So 20 divided by 52 gives me a decimal of 0.38146, and 2 divided by 4 is 0.5. So when I add these together, I get 0.8816, and that's my expected value. Now, how does that compare with what I actually bet? I bet €1 to win 88 cents. Absolutely forget about it. Bad. So what's my estimated return? My estimated return is my estimated value minus my investment, which is 0.8816 minus 1. And that will come out in negative territory of minus 0.6154, which is, again, bad idea. But by the way, it's fine for you just to get the estimated value and compare it back to your investment. That's fine. That's okay. That's just another step along the way. If you want to go that far, you can say, well, what's my return? Take away your investment from your estimated value to see where of the 3 does it leave you above 0, equal to 0 or below. It's just an extra layer of proof. You don't really need it. To go as far as there would be perfectly fine. Okay, the next one. Page 89, question 7. 2 spinners P and Q are spun and the sum total is noted. Okay, so the sum total is noted. Copy and complete this probability distribution table. Okay, so the totals that they want us to work with are 5, 6, 7, and 8. Okay, so I have to ask myself now, what's the way of getting 5 from both spinners? Well, I could get a 1 and a 4. There's no other combination. So to get 5 here, it's 1 and 4. Okay, how do I get a 6? Well, I could have a 2 and a 4, or I could have a 1 and 5. Okay, how do I get a 7? Well, I could have a 2 and a 5, or I could have a 3 and a 4. And how do I get 8? Well, I could have a 3 and a 5. Now, listen to all the language in there. 1 and 4, 2 and 4, or 1 and 5. So what we have to do for each of these is write down the respective probabilities. So probability of getting 1 from the first disc is 0.25, and means that we multiply. The probability of getting a 4 on the second disc, 0.5. Okay. Probability of getting a 2 on the first disc, 0.25. Multiplied by the probability of getting a 4, 0.5. A 1 on the first disc, 0.25. A 5 on the second disc, 0.5. A 2 on the first disc, 0.25. See the idea? And 5 is 0.5. A 3 is 0.5 on the first disc, and a 4 on the second disc is 0.5. And lastly, a 3 is 0.5 and a 5 is 0.5. Wow, okay, so now what we've got to do is work out these products, and then the word or means you're going to add these together. So we're going to get a probability for each of these, okay? What is a half of a quarter? Half of a quarter is an eighth. That's done for me, okay. Then we've got half of a quarter, which is an eighth. Then we have a half of a quarter, which is another eighth. So an eighth or an eighth means an eighth plus an eighth, which is 2 eighths, better known as a quarter. Okay, a half of a quarter is an eighth, and a half of a half is a quarter. An eighth and a quarter, well, don't forget a quarter is 2 eighths, that's 3 eighths. And then you have half of a half, which is a quarter. There. So we've got an eighth, we've got a quarter, we've got 3 eighths, and we've got a quarter. So they are the probabilities of each of those. Part 2, calculate the expected value of the sum. Now that just simply means that you take the probability and you multiply it by the value on top. So therefore, the expected value is equal to 5 times an eighth plus 6 times a quarter plus 7 times 3 over 8 plus 8 times 1 over 4. Now, if I've done that correctly, that should be 6.75. Okay. 6.75, that's your expected value. Part 3, so that's part 2. Part 3. Daria and Daniel play a fair game in which Daniel spins the 2 spinners. If the sum on the spinners is 5 or 6, Daniel gives Daria €1. If the sum is 6 or 7, Daria gives Daniel n cent. Find the value of n. Now there's 3 things here. First of all, look at the word that's in bold. It's a fair game. What does that mean? That means that your expected return is nothing. If it's fair, it just means you get your money back. So a fair game means that the expected return and the expected value are the same. So in that case, what that transfers to down here is that the probability of getting a 5 or a 6 has to be equal to the probability of getting a 7 or an 8. So what's the probability of getting a 5 or a 6? And go back to when we talked about mutually exclusive and non-mutually exclusive. Can you get a 5 and a 6 at the same time? No. So these are definitely mutually exclusive, which means we just add their probabilities together. So probability of a 5 is an eighth, or means add. Probability of a 6 is 2 eighths, which gives me 3 eighths. Fine. Okay. What's the probability of getting a 7 or an 8? Well, the probability of getting a 7 is 3 over 8. And again, they're mutually exclusive. So the probability of getting an 8 is 1 over 4. 1 over 4 is better known as 2 eighths. That's 5 over 8. Now, what does that mean? That is the probability of getting a 5 or a 6. And that is the probability of getting a 7 or an 8. Now let's work down to the expected value, because here's what we know. The expected return has to be nothing. It's a fair game. So the expected return has to be nothing, which means when you multiply both of these by their prize value, and we're talking about cent, by the way, as well, don't forget that. So we're dealing with cent. So that means it's €1 is 100 cent, and that's going to be n. So in this case, if it's a fair game, 3 over 8 times 100 should be equal to 5 over 8 times n, because it's a fair game. It can be no money either side. It's fair test, so that means, or a fair game, which means that the expected value and expected return are exactly the same. Now, this is easy enough. N equals, well, take the 5/8 over here and make it 8/5. That means the 8's cancel, and you get 3/5 of 100. 5 into 100 goes 20 times 3. That's 60. So the answer is 60 cent. Okay. Question 15, page 89. The number of laptops per household in a survey of 100 houses in a town gave the following frequency distribution. Okay, so the number of houses with no laptops was 10. The number of houses with one laptop was 75. Number of houses with two is 10. Number of houses with 3 laptops is 5. Draw up a probability distribution table for the variable x, where x is the number of laptops in a house picked at random in the town. Now look, draw up a probability distribution table. That's enough. So you have number of laptops, okay, and you have the frequency. And then I want the probability down here. Okay, number of laptops, none, 1, 2, and 3. There are 10 houses with none, 75 houses with 1, 10 houses with 2, 5 houses with 3. So therefore, what are the probabilities? Now, the probabilities are all going to be out of 100 because there are 100 houses. Okay, so 10 out of the 100 have none, 75 out of the 100 have 1, 10 out of the 100 have 2, and 5 out of the 100 have 3. So there's your probabilities. That's the important line. Okay, so draw up the probability. That's it, done. Part 2, so that's the first one done. Part 2. Find the expected value of x. Now, the expected value is the probability multiplied by the number of laptops, yeah, because that's the value of each of these events. So the first one is going to be 0.1 multiplied by 0, which is 0. 0.75 times 1, which is 0.75. 0.1 times 2, which is 0.2. And 0.05 by 3, which is 0.15. And if I add those together, I get 75, and that is 0.9, 0.2. That's 1.1. That's it. Okay. Part 3. Find the probability that a household has 3 laptops, given that there is at least 1 laptop in the house. Now, find the probability that it has 3 laptops. Well, first of all, what's the probability of having 3 laptops? Haven't we just worked that out? The probability of 3 laptops is 0.05. Okay. Given that there is at least 1 laptop in the house. Now, these questions with the words at least, I told you what to do with these. If some question says give the probability that at least, you ask yourself, what is the opposite statement to that? At least 1 means that they could have 1, they could have 2, they could have 3, but they can't have none. So therefore, instead of looking at least 1 laptop, let's look at 1 minus the probability of no laptops. So 1 minus the probability of no laptops. What does that come out as? Well, that comes out as 1 minus, what's the probability of having no laptops? 0.1, which comes out as 0.9. So the probability of 3 laptops, given that they have at least 1 laptop, you just put them into fraction form. And 0.05 divided by 0.9, make sure your calculator is on first, usually helps. So 0.05 divided by 0.9 is equal to 1 over 18. And that's the probability that a household has 3 laptops, given that there is at least 1 laptop in the house. Okay, so I've done enough of those. Time for you to work on these now. Page 88, page 89, and page 90. Take your time with them. If you have questions on any of these or difficulties with them, you may email me and I'll get the solutions back to you as soon as I can.